and welcome to the Daily Space Weather. Starting things out looking at Sunspot 2822 and all of its ionized helium glory. 3 C-class flares happening in this 24-hour run of the northeastern limb of the closest star. Here's a zoom out of the full disk in the same wavelength. Likelihood for additional coronal, not coronal holes. Likelihood of additional solar flares and coronal mass ejections still there. Strong storms in the Midwest and an earthquake lull. All to be covered and more in today's Daily Space Weather. We'll also talk about BL Lacertae objects briefly. Here's 193 angstroms. Some diffuse coronal hole systems down here in the south. And we'll talk more about coronal holes later in the video. The main solar feature, besides sunspots, is indeed coronal holes. They give us all kinds of insight into the progression of solar cycles as well as the magnetic fields. Here's a diagram of the solar system. Keep in mind it's not to scale. And there's where things will be in a week. Here's a star chart. We'd like to draw in the ecliptic and face our star chart to the south. As I'm currently facing the south, it helps to orient me. If you're up before dawn, you may see the moon, Jupiter, and Saturn rising ahead of the sun. And you're unlikely to see Venus as it's rising behind the sun right now. The 10.7 centimeter radio flux, the radio output from the upper chromosphere and lower corona, is at 76. Here's a 1-year chart of that. It's the black line. The red line is the sunspot number. And here's just the solar intensity gram from the Space Weather Enthusiast dashboard. Sunspot 2822 is indeed a beta-class sunspot and does harbor the possibility for additional significant solar flares, including the possibility for another M-class flare. X-class flare fairly unlikely with that sunspot. Here's what we're talking about when it comes to lulls and earthquakes. You can see it's been back in March was the last time we saw a 7 magnitude earthquake here on planet Earth. And we know how earthquake lulls end, folks. They end in earthquakes. So here are the 5+ magnitude quakes. We saw one in Mongolia, one north of India there, north of the Himalayas. Also one at Papua New Guinea, and one down by the Antarctican plate boundary there. And it looks like we also saw a quake there in the mid-Atlantic area. For some reason not showing up on the USGS map. I think I have it filtered for only no, it's showing smaller magnitude quakes there, folks, so I'm not sure exactly what is up with that. Let's see if we can find that on the list here. As it is not showing us what time that came in. So here's the report on that quake. It remains unconfirmed. Also magnitude unknown. 19 miles northeast of Lawrence, Essex County, Massachusetts. Coming in as we did show prep actually today at 8:56 Greenwich Mean Time, Universal Time, Zulu Time, whatever you'd like to call it. Depth unknown an unconfirmed quake. If you felt that one, let us know in the comments. Please share your experience and perhaps submit a report on volcanodiscovery.com. Volcanodiscovery.com. Here's the USGS list. We're just going to scroll up the list here. We reported a bunch of deep quakes in yesterday's daily space weather video. There was a deep one at Fiji at 118 kilometers at a 4.7 magnitude. Also, Tajikistan saw a 4.4 at 115 kilometers depth. And just scrolling up the list, it's the earthquake lull continues. And as far as volcanoes, we see Subanose-jima continuing to explode, producing a 9,000-foot ash plume. Canalone in the central Philippines. A possibility of phreatic eruptions showing up there. So this volcano could explode in the central Philippines there. Canalone, now back on the list, producing sulfur dioxide emissions at 96 tons per day. As of yesterday, as well as other emissions, a 300-meter steam-laden plume, raising the possibility of phreatic eruptions. And if you're wondering what phreatic means, it means well or spring, associated with a well or spring. So phreatic eruptions are commonly associated with volcanoes exploding. Semeru. An uptick at Semeru there, 14,000-foot ash plume above it at East Java. Popocatépetl, exploding in central Mexico, 19,000-foot ash plume there. Volcanic ash not observed at Pacaya, but Pacaya in Guatemala back on the list, as well as Fuego, which is exploding, 16,000-foot ash plume produced by the Guatemalan volcano Fuego. Revenador exploding, 15,000-foot ash plume there. And Sabancaya reminding us as it explodes that it's produced a 23,000-foot ash plume, which is not something to pole vault. So please don't pole vault the caldera. We need the subscribers and viewers and shares and so on YouTube. Please do not pole vault the caldera. This public service message brought to you by smAsho.com. Today's featured product is the Vaccinate This products. Since my vaccination status is none of your business, those not responsible for your health care and the administration thereof have no legal right to any of your protected health information. You can find links to that at smAsho.com. It's the smAsho merch shop. We've got like 50 products with the Vaccinate This theme on it. Let's get back to the sun-facing suite of instruments on the GOES 16 with the GOES X-ray flux. And you can see those 3 C-class solar flares over the past 24 hours, as well as that M-class flare happening on May 7th. Here's the proton flux, and we don't see any spikes in the proton flux. It would be no surprise to our regular viewers as we do things like forecast coronal mass ejections. None are currently on the way. Here's the 3-day chart of the GOES magnetometer, also measured by the GOES 16, like the proton and X-ray fluxes. The GOES magnetometer looking fairly smooth here over the past 3 days. Here's the heliospheric current sheet. South pole polarity shown in red, north pole polarity shown in green. And we see the opening up of a green north pole current sheet on the way to Earth right now. Possibly an indication of some additional sunspot activity in the southern hemisphere. We'll be keeping an eye on it. And when I say eye on, the pun is intentional. Here's another view of the same data, the line of sight ecliptic plane field plot. You should see the blue line being pulled down there, and indeed you do. Some more progression of cycle 25 as the field reversal process continues. Here's a line of sight coronal hole plot, and you can see this rather diffuse series of coronal holes in the south here, not very well defined. And if we do see a coronal hole wind stream from those, it's not expected to be very extreme. And you can see the sun's B field moving a bit here with the imagery. The west side being pulled toward the south. And also the east side being pulled toward the south at the end of the video. And for you new viewers out there, this is the east side of the sun, and this is the west side of the sun, because things like sunspots, set over here in the west and they rise over here in the east. That's why that's the east and that's the west. Because the sun rotates faster than the Earth orbits it. It takes about 27 days for a Carrington rotation, one rotation of the closest star. So here are the coronal hole and detected sunspot groups on the Integrated Space Weather Analysis Center. Sunspot 2822 remains a beta-gamma class sunspot. So again, likelihood of additional solar flares remains. Don't be surprised to see another M-class flare and to see additional coronal mass ejections in the coming couple of days. The KP index, a measurement of global geomagnetism. Global geomagnetism is currently at a KP1, the planetary K index. Next, the real-time solar wind, one of the regular features we show daily on the Daily Space Weather. Here at Smash News Network, least busted name in news. Current conditions are solar wind density just under 6 protons per cubic centimeter, solar wind speed only 321 kilometers per second. It's a weak solar wind speed, and it's producing weak magnetism in the geospace. So here is the 4-hour geospace magnetosphere movie showing pressure. And we see a fairly homogeneous pressure here over the last 4 hours. Nothing too exciting going on in the geospace. This is showing you about 12 Earth diameters of magnetohydrodynamic pressure in nanopascals. We'll also show you geospace delta B ground magnetic perturbations shown in nanotesla. Changes in the Earth zone B field. We showed you the suns. Here are the magnetic perturbations on Earth's B field. And pretty uneventful over the past 4 hours here. Generally, weak solar activity continues well into solar cycle 25. Now, we do regularly stream live to Twitch. It's twitch.tv/smAsho. And let's welcome our Twitch viewers. Welcome, Twitch viewers. We've decided to stream live for the cosmology segment. Before we get into the cosmology segment, again, I would remind our other viewers to check out twitch.tv/smAsho. It's a fantastic mobile streaming and live streaming platform. They've got a great mobile app as well. Thanks to our new subscribers over on BitChute. Look for more exclusive content coming there, as well as old exclusive content, such as this video about hydroxychloroquine. Thanks to our subscribers over on YouTube. And if you're watching any place besides YouTube, I would remind you that the majority of our content is indeed on YouTube. It's very feature-rich. It's got playlists. It's got live streaming. It's got all kinds of other community features. YouTube.com/smAsho, the main location for our video content. Today's cosmology segment will be rather short, and we're going to pick a random number between 1 and 1031. Actually, I already did that. It's 651, which is a BL Lacertae object. And if you're wondering what BL Lacertae objects are, they're a type of active galactic nucleus which has a full spectrum range and variability. Now, BL Lacertae objects were originally believed to be extreme variable stars. But with Edwin Hubble's realization that the Andromeda Nebula was actually a galaxy, BL Lacertae objects had to be re-evaluated. Turns out they're active galactic nuclei. They're the cores of galaxies. And basically it has to do with orientation. It's similar to a quasar, although the variability is a little bit different in terms of their emission spectra. BL Lacertae objects are variable, and they have a full spectrum non-thermal emission coming from them. If you want to read more about that, feel free. It's the Wikipedia article here on BL Lacertae objects. A type of active galactic nucleus, similar to a quasar. So let's go and take a look at this particular one. Again, it's number 651 on the Neil Gorell Swift Bat X-ray Observatory. It's Quasar B 1722 plus 119, a catchy name. Here it is on the Pan-STARRS. And here it is on the 2MASS. And I think that actually might be a related satellite galaxy there, folks. Let's take a look at it to see if it shows up in hydrogen alpha, and it doesn't, unfortunately. Let's see if it shows up in the Galix, which is the UV emission spectra. And that's an indication that this object here is probably not related, as the UV spectra is completely different. Let's see if it shows up as an X-ray source on Chandra, and it does not. And it's also not on the XMM Newton. Is it a gamma ray emitter? Nope. Anyway, here it is on the Pan-STARRS once again, Quasar B 1722 plus 119. And I would suspect that this object here is probably a foreground galaxy, or it could even be a star, believe it or not. I would also invite our viewers to check out our other cosmology segments. We've got 179 videos in there currently while recording this video, and by the time you see this, there's going to be 180 videos in there, most likely. I would invite you to check out this one. It's entitled Cosmology Segment. Quote, "It's hard to make predictions, especially about the future." One of my favorite cosmology segments. Also, this one here, the one the day before, Metallicity informs us the concordance stellar evolution model is invalid. youtube.com/smashamash/playlists. And let's move on to the astronomy picture of the day. You can look it up yourself. You can find the astronomy picture of the day at apod.nasa.gov, apod.nasa.gov. And this is the Orion Nebula, which includes the Horsehead Nebula, which is this down here. You can see the little horsehead looking area down there, as well as this nebula up here. I don't know what it's called, but this is only at about 1,500 light years, the Orion Nebula. NASA's astronomy picture of the day. And that's today's cosmology segment. Thanks for tuning in, folks. Don't forget to press like and subscribe, by the way. And I've been your host, Dan, a.k.a. smAsho. Let's get back to the daily space weather. We'll have to say goodbye to our Twitch viewers. We'll bring you back for the meteorology segment. Next, we've got a diagram of the Van Allen belts. We show it daily to visualize what we're showing you. It's a NASA image of the Van Allen belts. It's showing distances in miles. Here's the electron flux of planet Earth over the past year. This is measured at about 300 kilometers at the F ionosphere layer. Here's a 3-day chart of the electron flux, which is in a normal and moderate range. We don't see any charging hazards. And the forecast is for similar and indeed lower levels. This is probably an indication that there is a coronal hole wind stream on the way. Again, we're not expecting it to be very exciting. It's a pretty diffuse series of coronal holes. Here is the total electron content forecast. And we saw very chaotic nighttime electron densities. Still a little bit of chaos up there. So once again, over the central Atlantic, we're seeing significant electron densities here at nighttime. So a bit of a disorganized Van Allen belt scenario going on. Seeing the likelihood of significant GPS errors at nighttime around the equator. And here's just the ionosphere layer around where this F is located at about 300 kilometers of altitude. It's an ionogram. And we're seeing a bit of anomalies here in the ionosphere as well. Typically consistent with when we see anomalies in the total electron content forecast. And let's bring up the latest image. We don't want the video to be too long here. Latest image coming in at 10:45 Universal Time. Things looking pretty normal at that moment. And let's welcome back our Twitch viewers. Welcome back, Twitch viewers. It's our meteorology segment. Let's do it. As we've got some strong storms over the Midwest. We'll get to it. First, the jet stream. And here's the chaotic jet stream of the Western world. And we see a big divergence here over the eastern U.S. There is a low pressure system over eastern Missouri right now. Here are the jet streams of the eastern world. Let's switch to surface winds. There are the surface winds. Chaotic winds here south of Australia. And we've seen this going on for quite a while here. Surface winds of the western world are next. And there you have those. Cold temperatures striking the eastern portion of the U.S. right now. It's unseasonably cold here in Pennsylvania. And I'm not a fan. And we've lost our lightningmaps.org. Come on, come back, lightningmaps.org. We're streaming live. Again, twitch.tv/smAsho. The mobile app will actually alert you when we stream live. Hey, Fort Wayne, you may be in the crosshairs for some lightning. Anyway, here's the global lightning map. We do see some terrestrial lightning here over the area south of Lake Michigan, as well as Missouri. Hey, Springfield, there's thunder rolling in. And I like to use lightningmaps.org when I hear thunder to convince my foes that I'm Thor. Here's the NASA Goes Lightning Mapper. Don't scare the natives. Heavy lightning here, mainly over the state of Missouri, moving into Illinois as we speak. Very strong lightning cells there. Next, I'd like to thank our patrons, a true source of funding for the content for these videos. Without you, our patrons, it would be unlikely that these videos will continue to exist. Please consider becoming a patron, as we are rolling all sorts of features into the continued content. And the operation is actually evolving in ways you would have no idea about because it's happening behind the scenes, thanks to Smash staff as well. Thanks to our patrons, patreon.com/smashamash, listed in order of total lifetime contribution. Next, pressure maps here on witty.com. We like to show the pressure maps daily, as it gives us insight into things like global weather patterns, and we're interested in things like facts here at Smash News Network. Least busted. Name and news. Here are pressure cells where they are now, and we'll advance this into the Euro forecast until tomorrow. Here's where we expect pressure cells to be at 12 noon Eastern Daylight Time tomorrow. Low pressure dominating the south geographic pole and high pressure dominating the north. U.S. Doppler radar map is next, and check out those heavy storms. That is extreme. Remember, folks, the most dangerous part of a storm in the northern hemisphere is the northwestern corner. And again, if you hear a violent storm coming in, check out lightningmaps.org. It'll give you insight into the worst part of the storm, where the lightning is located. It's telling you the most violent part of the storm. Know where that is, and check out all the snow falling in North Dakota, South Dakota, Wyoming, some in Colorado yet, and a large portion of Montana seeing continued snow on May 9th. Apparently it's so hot that it's cold in Montana. Here's the cloud layer, and here's the water vapor map. Again, the cloud layer and the water vapor map. And this system is actually going to move rather slowly. It doesn't have a lot of impulse pushing it along, and there's not a very strong low in front of it pulling it along either, so it's not going to move all that quickly. Although it's not butting against dry mass of air either. This dry mass of air back here is not providing any sort of a push impulse to the east. Again, there's the cloud layer. And there is the U.S. Doppler radar map. And that's today's meteorology segment, a regular feature of the Smash News Network. See you later, Twitch. Here come bonus features for our daily space weather content. allow me to vanish. And so here's the latest from, we'll go to El Teide, Spain. They must have the day off for Mother's Day. Happy Mother's Day to all of you moms out there. Happy Mother's Day to Mothra. Here is the current situation in hydrogen alpha from the El Teide, Spain. The data is an hour and 40 minutes old, but we do see filaments up here, which could be ejected by activity from this sunspot, Sunspot 2822, and it looks like we actually caught a flare here. You can actually see a brightening in the southern portion of that on the video. We actually caught a flare once again while making the video. How about them apples? And here come the remainder of our bonus features. It's the colorized magnetogram. We may see another sunspot forming here in the south. Did I forecast that earlier in the video? Well, I don't know. Anyway, there's the magnetogram and there's the intensitygram. What this is showing us is that this is a South Pole umbra and this is a North Pole umbra, which makes that a beta class sunspot, and the likelihood of solar flares, again, folks, is there. And the North Pole umbra much larger, and it's actually at a higher latitude. Usually we see sunspot groups at a similar latitude. Those are located in a north-south orientation to each other. And we'll close things out with a couple more views of the closest star here. Here's a full disk 171 angstroms video from the Solar Dynamics Observatory. And we've got some additional wavelengths for you here. It's the close-up of Sunspot 2822. There should be 3 C-class solar flares in there. Let it play through a second time. And I think we've got 2 more wavelengths for you. 335 is next. Here's 335 angstroms, another iron ionized ultraviolet light emission spectral state. Yes, hot gaseous iron emits ultraviolet radiation. And there it is, 335 angstroms. And last but not least, 94 angstroms, another ultraviolet spectral state of ionized iron. Anyway, thanks for tuning into the Daily Space Weather. Remember to press like and subscribe, press share, tell your friends and foes about the videos. And since it'll never be now again, may that solar wind be at your back.